welcome to my session. Thank you for joining. So first of all, quick disclaimer. I'm not coming here to hype AI anymore. I'm not here to sell you any Kool-Aid, as we say in the US. And also introduce myself. I'm a data scientist at Syngenta. It's a Swiss-based company in agriculture. I'm an author of machine learning books, the latest of which is going to come out next year, called Do It Yourself AI. I mostly focus on interpretable machine learning, which is kind of like debugging a model, machine learning model. And this is actually my second career. I was in web development for a long time. And so without further ado, let's dig in. So first I'm going to go over the hype a little bit, then the hope of what comes next, then a roadmap, and then a quick recap. If that's all okay with you guys. Okay, as far as the hype goes, this is like the Google searches. As you can tell, there was a spike where artificial intelligence, somewhere in like 2021, 2022, just like took off. So it's become more relevant as far as web searches go than computer science. Like that's equivalent as, you earning more, like 20 times more than your boss or something. It just doesn't make any sense. Because computer science is like, mathematics, the father of artificial intelligence, I think. So it makes no sense. And well, we've all seen headlines like this. Of course, I mean, the Terminator-like future is not coming anytime soon. I think it's completely overblown, especially once you know what's under the hood. And we'll get into that in a bit. And as software engineers or developers, you've probably seen this, like Devin, how it came out this year, and apparently was going to do your job. That's not happening. For any of you that already tried Devin or any of these tools, all they can do is assist. They're not replacing anybody. And recently, we got Sundar Pichai claiming that 25% of Google's code is made by AI. And as much as that may be true, I mean, it's pretty much auto-completing a bunch of stuff. So it's still providing assistance. It's not like doing entire programs from scratch. That's not happening. And we get like the ex-Google CEO Eric Schmidt predicting that AI centers will be on military bases surrounded by machine guns. Of course, we all know data centers are valuable, so that might happen regardless. It's not necessarily because, okay, AI. I think that's completely overblown. And you could say, well, it's all driven by money. Isn't everything these days? So, and yeah, that to a degree is true. Like if we see the collective market capitalization of the big tech companies over the last 10 years, how it's taken off eightfold just the last 10 years. And this is crazy considering, well, $16 trillion is just a few trillion dollars short of the entire GDP of all of the European Union, which is 19 trillion. So just put that in perspective. I can't think possibly there's any reason for these 6 companies to have that value. And the only thing they've delivered over the last 10 years, there hasn't been iPhones or there hasn't been anything revolutionary. All they've done is incorporate AI into their products. And I can't say the productivity gains have necessarily equated to that. So it's remarkable, really. I'm addressing the elephant of the room. I work in AI, and I'm not here to tell you what you're hearing on the news. It's definitely going to parallel something else, which I'll get to in a bit. But it's right now it's completely overblown. So, and there's also a good reason for it, which has nothing to do with money. And I don't know if you're familiar with this guy, Jaron Lanier, but he says AI better understood as a belief system instead of a technology. Indeed, it's one of those things that we've carried for a long time. This desire to create something that can, there's that aspirational quality that can have human-like intelligence. And we've had it for a long time, even Middle Ages. We can go way back, this idea that we would create like an automaton or something that kind of mirrored our intelligence and our capabilities. So it's not just in science fiction, it's also in machines we've made, in ideas we had, in books we've written, devices we've created long before computers existed. So next I'm going to go over the hope. And I'm going to focus a bit more on this section because I think there's a lot to say about what can it do and what can it not, and how it relates to the present. So we're going to go back into a time machine to 1999, 25 years ago. I don't know if I look this old, but I mean, I was in university getting a bachelor's in computer science, and I actually was very proud of getting my first paid job. And my first paid job was actually in web development. And it was the exciting new thing going on then. And I had been working web development. I had been making websites since, earlier in high school, before it was a thing. And when I would tell friends that I was working in web development, they would say, "Oh, the internet's the future, and you're building it." And yes, I'd be really, really excited. I'd be working on the future. It's the same thing I hear right now when I tell people I work on AI. And it's kind of crazy because when you're working on something like that, it doesn't feel like it. It doesn't feel that revolutionary, and honestly, it probably isn't, because it's a slow build up to that. And of course, there was points in time where people would be like, this is another hype cycle, because they've been burned a lot by these hype cycles, with all the crypto and everything going on. Every few years there's a hype cycle of some kind, and it doesn't amount to something every single time. And then 2000, something did happen. And it was just a crash. It had everything to do with those market capitalizations I was talking about. It had to do with Wall Street. It didn't have to do with what's actually happening on the ground. Because we look at that, this is like the S&P 500, it reached that peak right there, and then you would see it would just dip. And you would think, well, the story ended there. But no, the story did not end there. This is just money. This is what happened. And that's just not really what I've come to talk to you about either, because this is what happened to Wall Street. But when it came to the internet, you look at how much adoption has been driven since just the year 2000. It's amazing. And so many new things that were actually revolutionary did happen, like mobile devices, like high-speed internet, like a lot of other things happened in that, and that's what gave the capability. It was more driven by hardware, it was more driven by actual fiber optics, cables being put across the ocean and things like that than anything else, and then people actually trusting the technology, which I think underpins this everything. And on Friday, I'm going to have a talk about trust. And I think it's, to a large degree, very, very important in this story. So we could say it's been a net positive in the world. I think it's brought the whole world a lot together. And I know this is a lot to take in this slide, but basically what it's saying is the whole world adopted this technology. Maybe not to the same degree, maybe not, at the same time, but within the last 25 years, it's brought the whole world into using the internet. And I think that's the story that's going to be told about AI in the next 25 years, for better or for worse. And I think hopefully it's more for the better. And I think it's been a net positive because of that closeness. And paradoxically, it's also done the opposite within countries. But that's a different story. So if we go back 25 years and we ask my younger self or anybody those days, the prophecies around what would happen with the internet would be a lot different than what they are today. But the most important thing is it's become a useful technology. So now we start talking back about the artificial intelligence and how it's been called hype before, and it's been said, oh, it's been peaked. So we really have to ask ourselves, is this everything? Is this where the story ends? And I think when the bubble pops, it's just going to be the same thing. It's going to become a useful and boring tool like every other technology we use today. We get very excited about it, and then at some point it becomes too much, and then it starts to fulfill some of the promises that technology was supposed to have to begin with, and then there's a point in time it's just something we take for granted. And so, like, the question I think that we have to ask ourselves is whether a computer can think is a more interesting question, whether a submarine can swim. In other words, do we think that we really are should be that focused of whether AI should become AGI? Does it have to reason like we do? Does it have to do everything like we do? It doesn't matter as long as it's useful. And I think it's very useful. And so, first of all, like, let's just demystify what makes it tick. So when we ask ourselves, what's under this hood? What's under AI? It's just a function, a mathematical function, and sometimes a very complicated one. And I'm overgeneralizing here. There's areas of AI in which it's not this case, but most of the AI we're familiar with, we deal with on a day-to-day basis, is exactly like this. So let's pose this example from discriminative AI, predictive AI. So let's talk about let's say hypothetically I have a deep learning model for predicting heart disease. So I just train a neural network that will look something like this. And this may look a lot more complicated than it is, but basically it just takes some inputs and it delivers an output, which is a probability that you'll get heart disease. And in between what it's doing, it's multiplying the inputs times a successive matrix and of numbers, right? And adding to additional numbers, and this is what we call parameters. So when they say a model has, I don't know how many billion parameters, that's what we're talking about. And this one has 26 parameters, so not a lot. And then also in addition to the multiplications, they're what we call nonlinear functions, and you can see those there. Those are applied in some of the steps. So when we turn this into math, we end up with this. And see, it doesn't look that foreign now, right? For those of you that are familiar with math, and which I'm sure all of you are. And so it's just something we can also put into a function, and they are. So when we actually build models from scratch, we do things like this. And this is in Python, of course, but it's just, as I mentioned before, just a successive multiplication of the inputs into outputs and so forth, just a chain going on, and with the nonlinear activation functions going in between. So you've all heard of large language models by now, of which GPT is one of them. And the large language model is pretty much that at the end of the day. It's just at a greater scale. So you imagine just multiple layers, I'm talking dozens of them, just successively multiplying times very, very large matrices. And so what we end up is with a whole, and this is basically an animation where you're able to kind of explore the possibilities in a large language model. In other words, if I type this word and this word and this word, it's going to predict the following word, and there's a probability it's going to predict other words as well. And so it just simply, that's what it does at the end of the day. It just predicts the next word. And to a lot of people that use it, it may seem like magic, but it isn't. We've probably already familiar with the terms discriminative and generative. So the heart disease example I mentioned before is a discriminative model. And this one is a generative model. And under the hood, they have the same they don't have necessarily the same architecture, but they'll build with the same kind of math. But the outcomes we expect are very different. So this is an oversimplification, but basically the way you can tell which one is which is in descriptive, you're meant to, take an X, whether it's an image, a text, music, or it could be like financial documents, and come up with a prediction based on that. So it could be, in the case of it took financial records, it might detect, what risk does this person have of defaulting on a loan? Or if it's in the case of an image, it could predict, this is this kind of image, or if it's music, it's this kind of genre, and so forth. But then on the generative side, we're taking pretty much a short description, or we're taking a number, and we're generating data with it. So it's going from Y to X. So that's an oversimplified way of explaining it. But regardless of what kind of AI we use, they all have weaknesses. And this is really the reasons why we wouldn't, and I would never suggest to replace all our software with AI. It would make no sense, because they're not inherently robust, they're not transparent, they're a pain to debug, and they use a lot of resources. So it's pretty much a tool that you wouldn't want to use in a lot of these cases. However, a lot of these issues can be mitigated to some degree. And so whether you think it's worthwhile to mitigate them and apply them, it depends on what level of risk you can tolerate. And so it's also another thing to be said about AI. It's pretty much garbage in, garbage out, and it's the same old story. It can only be good as the training data. And so next, what are the strengths about AI? It's very good with dealing with uncertain situations, complex problems, anything that needs to be automated that has those elements and scaled. It's good at generalizing to some degree different problems, especially if they have these other elements, if they're uncertain, complex. Fortunately, this is a very common type of problem in human life. And so, since it excels in uncertain, ambiguous, and complex problems. That's to be said, it's important to say that, well, since there's a tolerance of risk that we have to determine whether it's worthwhile to use AI or not, it's important to say, well, should we have humans in the cockpit? Of course we should, at all points. I think because we have to guide their design and build these pieces, and we also have to monitor them. And there's good reason to do that. As I mentioned earlier, I have a talk on Friday that goes into that a bit deeper. But even in an AI system, the AI model is only one piece of the system. So regardless if you think, well, like AI is going to take care of everything, it usually doesn't. It involves a lot of different tools and coming into place, and actually people that develop them, monitor them, and maintain them at all times. So I think it's not going to replace any software engineers, precisely because it just requires so much orchestration, and it also requires so much supervision. And even if it didn't, I think it's also doesn't apply to every single problem. So here's the exciting part. What's a roadmap? What do I think every software development team should be doing at this point? And so I go back to what Alan Kay said. The best way to predict the future is to invent it. So I think there's a lot of human creativity in this room and in the world that can be leveraged to use AI to the way it best suits us to do our best work. And that doesn't mean getting ourselves out of the equation. It means definitely injecting every sense of what we're trying to do into the equation. So the level of that is basic AI understanding. And to a large degree, I think we're already doing that right now. For those of you engaging in conferences, this is already part of what you're doing. And so it's basically about learning AI at the technical level and depth required for your role. What I call AI whispering, learning how to talk to machines through language, because at least for a while, that's going to be a way to engage with these models. Prompt engineering, it's called. And then another important aspect is as certain of the issues with AI become, ironed out, it probably will never be, is also be very vigilant as misinformation and bias detection. It's not always nefarious. It's sometimes you're working with a model and it hallucinated. Don't get fooled that it's always going to be that just because it got the last time 10 times it was right, this next time you use it, it's going to be wrong, and you won't notice. So don't become complacent. That's my advice. And then how you learn it. I mean, as I said, we're doing this right now through conferences. There's books, so you can get in deep into topics, subtopics that interest you. There's nobody, I laugh at anybody that says, oh, I'm an AI expert, because there's just no way to know everything about that field. It'd be far more credible if someone said, well, I'm an LLM expert, or I'm a computational biologist, and I work with deep learning in biology. So, your expertise is in that area, and that's fine. So I think it's just going to be something that is going to be specializing more and more, and it's really important that within that area you find a certain niche, not because you necessarily want to become an AI engineer or a data scientist or anything to that degree, but because it's going to become a tool that you use in your work. Just like the internet has become a tool that we use for the last 20 plus years. So another thing, of course, there's courses, and you can get deep into that. You can get into podcasts, blogs, newsletters, whatever kind of speaks to you. And when to use it. Of course, I would say, well, as far as ideation, innovation, and I'm sure a lot of you have gone that rabbit hole, trying to do something creative with ChatGPT or DALL-E and so forth. But it can also be applied to kind of how do I think outside of the box with a certain kind of problem you have at work. You say you're coding something and you want to think, how can I solve this problem differently? And sometimes that's a way to break it. And so also it can enhance decision making, it can save time, and of course, as long as it's not risky. So just take a leap, but not off a cliff. That's what I like to say. And so know when not to use it. And this is really important. We've all seen those emails. They're super annoying. And you say, this guy used AI, right? It's too long. It's too kind of flowery. It's no way a person read it. And then it's just too much. You're getting too much every day. And you have sometimes there's a need to also summarize things. So it makes no point to be communicating with someone, at this level, So just kind of drop the bullshit and try to use AI in a way where it's not causing everybody more work, because this is more work, I think. Another thing is, well, to explore and play with AI tools and open source code. I think it's really important to explore, because that's how you're going to find what areas you want to focus on and learn about and apply in your work. And that's also going to vary according to your role. If you work in security, it might be something security related. If you work in project management, it might be involving project management. In these examples, I'm going to focus in the programming aspects to some degree, but even then, it's not everything. Coding assistants, they might make your life easier to some degree, or maybe they don't. They're just a nuisance. But there's even aspects of coding assistants that are coming up all the time. They're new, and you figure, well, this is something I could use. Personally, I don't ask these coding assistants to create code for me because it's usually crap. But I do ask it to make documentation because I hate making documentation, and it does it fairly well in my experience. But it's not just a question of preference, it's a question of skill, and it's a question of interest. So TLDR, this is another tool for meeting assistance, and this is a lot of times we're having a lot of meetings throughout the day, and it becomes a bit of a cognitive load to take notes. So I think there's a big need for these kind of tools. And even for learning, I would say probably even more. This field, not just AI, but development in general, there's constantly something new, and it becomes really taxing to be on top of everything. You just want to get the summary. So you figure, well, is this worth probably learning in more detail? And then once then, maybe it can aid you in the actually studying process, so you become competent in these new skills. So it makes sense to, okay, why would I invest time in a 50-minute video tutorial on something without kind of figuring out what are the key points and seeing, well, maybe I want to fast forward to the part that I truly want to look into. And then I mentioned a bit into this before, but ideation, there's more and more tools for ideation. So exploring a topic, branching it in several levels. This one is very, this is for storyboarding, but there's tools for all kinds of work. If you used Mural or anything like that, you probably have engaged with these sort of aspects. And then for those of you working more on the UX side or working from a design standpoint, there's also tools to take the designs and turn them into functional prototypes. Maybe not the finished product, but I think that is helpful in the sense that sometimes there are parts that are of a product that are more deterministic, less risky, but very time-consuming. Those are pretty much low-hanging fruit for AI. And then, depending on how deep you want to go, you might want to get into pre-trained models. So for that, you can go into Hugging Face Hub. You can get a lot of the models there, whether it's Llama, whether it's whatever new model came out, it's most likely going to be there. And then many models have spaces where you can try before you buy. Well, you're not necessarily buying, but try before you download and invest some time in it. And then a lot of these also stem from GitHub repositories, where sometimes you find model weights, but more likely training code. Whether you want to take this training code and use it on your own data, it's up to you. But you can also look into papers with code, where you'll find like the research papers where a lot of these stem from, and then find the code for the latest research through there. So say you're working, as I said, you're the security researcher, and you found someone built a very good model for detecting fraud. And so you go to that paper in Papers with Code, and it'll point you to the GitHub where you'll find the code for it. Or alternatively, you might find it in Hugging Face Hub. And then there's, of course, foundational model APIs. You could get an API key with Claude, or you can get it with OpenAI, or you can get one with Replicate, which has a lot of different models for a lot of different use cases and use it there. Or, of course, you could use one of the cloud services ones, whether it's Azure or AWS or whatnot, and engage with foundational models there. But I said there's a whole world of machine learning models outside of what is talked in media, of what is available in cloud services and even in Replicate. So I suggest you also look into the other options. And then there's no-code and low-code tools. There's plenty of that. There's general purpose workflows. So you got things like Clarify, like Vertex AI, like Databricks, and they have a lot of no-code options. And if you're like into visual generative AI, you might use something like Comfy UI or Automatic 111 or Forge, which are options for creating workflows for generating images or even video. And then for text generative AI, there's also visual options for creating chatbots. And this is outside of what's available already in cloud services. So you have, these are open source, Langflow, Flowwise, and LandGraph Studio. So another part of the exploration process, this is for like exploration, exploring services, exploring resources and tools. I also suggest, well, why not apply some of that at home, in your spare time? Take that knowledge and find a passion project, and then and how do you find a passion project? You find an intersection of two questions. What are you passionate about? And what problems do you face day to day that could be addressed with AI? And maybe there's something there. Maybe you have a collection of, I don't know, of something and you want to organize it. Or maybe you like birds and you want, and in the spring you want to be able to detect when the bird arrived and take pictures automatically. Maybe there's something in your life that you could apply, and then that could be something that become useful later in a work situation. Or maybe just create more understanding around what AI can do for you and what it cannot. And so once you find this passion project, you want to explore possible ways of doing it. So that's when I tell you, you go back to the GitHub, or you go to Hugging Face and you find models that already did that, or even Kaggle. Maybe you find projects that already been built, and maybe they have a small difference. Like give you an example. Halloween just happened, and I look for projects. What have people done with generative AI to kind of have this haunted mirror situation where children come to your door and they look towards a screen and their image is in the screen, and then their face turns into a ghost or something. I thought that'd be a nice way to greet them, and so I found projects that were like that, and I had code that already did similar things with generative AI, and I pieced them together. It's just something fun to do. Then maybe you can write about it. If you fail in public, it's okay. We're all learning. And so that's, you can, once you've drawn inspiration from similar projects, you can probably, maybe your passion project changed slightly. And then implementation is just about taking all the parts that you found already that are relevant to your project. Okay, you found your project needs this component, or this needs this model, then you put it together. And that's probably not a part I have to lecture anybody around here, because as developers is part that comes natural. But and then, as I said, documenting the process is important, because since we're learning something new, it's important to document it as you go along, so it reinforces that learning. And then something that's really important is to evaluate and refine. You can build that model, but then, or you can build that passion project, and then start refining it with what you learned. How did it fail? If it failed, and how can you improve it? And that part is often really tricky with AI, but it's a part that provides a lot of room for growth, as it does in every project, because AI being not the same as software in terms of its determinism and so forth, it becomes very easy for these things to fall apart without you noting. Like for instance, like I was saying with the example I provided with Halloween and the children, there's so many ways it could fail. That maybe have nothing to do with the model. Maybe it's the camera, where it's placed, like the resolution, the latency, things like that. So those are become very cool, like engineering projects on their own. And then finally, well, how about agentic AI? And that's probably the most exciting development. You tell me the most exciting development over the last few years hasn't been large language models for me. It has been agentic AI. And for now, what pieces them together are large language models. But for me, they're by no means the only way to make this work. And so what agentic AI it is basically you have an agent that uses LLMs not only for communicating with a human, but also to generate code, to and using that code to engage with external tools and knowledge bases. And also there's a reasoning process, if you can call it reasoning, that plans the steps that agent takes that are done by the LLM. So it's also important to incorporate guardrails into that process. But to me, that's the most exciting thing. So off to level 3, which is developing custom AI solutions for work. So once you've learned the ropes, understood, what it is that AI can do for you, even all these levels I'm going through, they're not necessarily done, sequentially. They can be done to some degree in parallel. But I think it is important to gain that understanding so you can move forward and apply these learnings. So with work situations, you're not going to be as playful and just try these random passion projects. But so it's important not to throw whatever spaghetti to the wall and hope it sticks. As we say in the U.S., it's important to be a little more thoughtful. But the process does mirror the passion project situation. Of course, there's more stakeholders and more people to work with, but it's also about finding valuable use cases, and also going through prerequisites and then implementation. And then it probably with a work situation, the thoughtfulness in the evaluate and refining part is a lot more. So you're going to focus there from the get-go. What metrics you should track, how should you track them, and whether a project succeeds or fail. The good thing is there's always the possibility to learn from it, and adaptability is also key. Probably even more in this work scenario at home, but it's also thinking, well, can I reuse these components? So AI, just like anything in software, it can be modularized, and it's key to think of it as just another module. Of course, it's something a bit more foreign because it's a pain to debug, and it has its quirks, but there's even more reason to track and evaluate it. So trying to wrap this up, I got a quick recap, and all it is this slide. So pretty much, if I had to summarize what I just spoke about, is that AI is too dumb to be a threat, but it can be useful. And then once adoption drives hype and not the other way around, AI will be boring as any other utility and pretty much as the internet right now. And that's what we all want. And that models are functions, mathematical functions, nobody should be scared about them, that approximate a solution. And the important keyword here is approximate. They're not a full solution to any problem. So never think of them as any more than that. But they can be certainly good for complex and uncertain problems with low risk and high reward. And also remember that for every weakness it has, there's also ways to mitigate them. And so it's important to be kind of vigilant, because it's not something that you set it and forget it. You have to be constantly on top of it, figure, oh, it has this kind of error. Let's see how we can fix it. And I'll dive deeper on that on Friday on my QA session. But the roadmap is all about learning about it, knowing when to use it and not when to use it, and explore AI tools, and find passion projects, and then find ways to also incorporate the same learnings at work. And then keep a lookout for agentic AI. I think there's many ways in which agentic AI can be applied to automate things at work with low risk and high reward. So that's the end of my session, and thank you for joining.